I'm pleased to introduce to the session Milvus Full Text Search, combining keyword precision with semantic power for next-gen data retrieval with our guest speaker today, Erbli Kuka. He's a data and AI engineer at Datamax.ai, specializing in ML and AI development and integration. He has gained deep insight into the transformers architecture, attention mechanism, and other critical areas of machine learning. He's passionate about machine learning, and Erbli is committed to advancing his career and ultimately leading teams to create innovative solutions in cloud development and AI. Erbli, the stage is yours.
Uh, Thank you, Stefan. Hi, everyone. So, yes, the this presentation we're going to be talking about combining the Milvus Full Text Search and embedding search to achieve something interesting, in my opinion. So the quest for this project started because I was in need of a certain tool that was able to crawl the web, whatever websites you can find, generate some data such as a title for the thing, a summary, basically to allow me to better find whatever pieces and chunks that I needed to help myself code a bit faster or understand like libraries better. So I will be sharing the presentation that I have made, and then we will go deeper into the demo, in which we will showcase how this whole logic comes together so that you can use it in the future. So, as I said, the key point of this presentation is about Milvus and their full text search and vector search. Sorry. So combining them, why would you need to combine these two retrieval methods? Well, simply because maybe some of them, for example, if you use a full text search, maybe you're going to miss a couple of details in whatever big document you are going through. Same goes with vector. They have their advantages and disadvantages. The key thing here is to make sure that you get the best of both worlds. And it's good to use Milvus because, as I will be showing you later, it is running locally on my Docker machine. And it's absolutely very fast and very reliable. It spins up in a couple seconds. So how do I even do this crawling of the Python or NPM libraries? I am currently using a GitHub library called Crawl4AI. I'm pretty sure that people who are in the AI LLM scene are very familiar with Crawl4AI. What it basically does is you can just crawl a specific website and it formats it or parses the most important things for the AI to better understand the context that it will get later. I have also developed some smart logic, in which I will touch on a bit later, that recognizes code blocks that you might find regularly in documentation in doc websites. It goes through so it uses the sitemap to go through all of the different websites that are inside a documentation website. And it makes everything ready for the AI to understand. And then after it crawls the websites, it creates embeddings and whatnot, puts them in Milvus database, and then we can access them later. So the Milvus full text search mechanism, what it basically does is, by the way, this is behind the scenes. So it's not like you get to see much of the Milvus part. It uses BMI 25 scoring to you give it some natural language, and then it generates a query. And then based on that query, it goes and retrieves the most relevant documentation or whatever chunks that you might have. Chunks are very important here. I will show it a bit later. The same goes with vector. Now, as I said before, there are advantages and disadvantages to them both. They are very strong solutions, each about their own thing. However, they do have a very big problem, especially in RAG, because at the end of the day, the solution is RAG, retrieval augmented. Yeah. The problem is that if you give it too much data or you saturate the database a lot, it will get confused. It will definitely get confused. So the workaround and why we are using both of them is that we are generating embeddings for each of the chunks. We are generating summaries for each of the chunks and a title just to have them a bit more. The title was just for show actually, but still we're using the summarization and we're passing queries to the summarization and the full context of each of the chunks. The chunk, as I said earlier, it is a bit varied from documentation side to documentation side, because one might have coding blocks and it has some smart logic to either read the whole coding block or stop a bit before that. Either way, to improve accuracy, to make it more redundant, better coverage, scalable, of course, because if you're going to be passing a full documentation of some NPM library, whatever, you might want to add on top of that a couple of libraries and whatnot. So why did we do this? As I said, the main problem is actually saturation. So for me, at least, one of the first projects that I've started with AI was a RAG. And I noticed that the second that you passed a couple hundreds or tens of chunks, actually, the embedding model would get very confused. And the solution used to be to just use rear anchors or things like that. The problem with rear anchors is that they can also get confused. So yeah, the solution to that is a agentic RAG. So the summary that we generate for each of the chunks, we also, in that summary, we specify which chunk it is and everything. And then we pass the queries, both vector and full text, we pass them to the summaries. And then we pass the most relevant result from the queries, both of them, to chat or whatever LLM of your choice. This, from my experience and from the experience of my colleagues, which have been using this as an internal tool, has resulted in very accurate results. I have yet to implement some logic that would differentiate libraries better and things like that. However, for what we use it, it's perfectly fine. And now I will be showcasing the live demo. The live demo will go as this. We will be crawling a website of my choice. In this example, I've chosen Pydantic because I had a project with that, so I thought, why not? I will showcase the sitemap logic and how that actually looks. And then after it goes through all of the, after it crawls all of the documentation websites from Pydantic, which it finds from the sitemap, then we can query it as if it were a regular RAG. However, we're not going to be using just one or the other, so neither vector or full text. We're going to be using both of them to have even better accuracy. Okay, so this is the script. I really won't go over too much. Yeah, I think the chunk size and the logic to find the coding blocks, that's like interesting in my opinion, and I'm sure whoever wants to can have a look at it. So I will be opening up the sitemap just so you have an understanding of how that actually might look like. This is it, basically. It has multiple links inside this one sitemap. Companies usually use this for SEO, search engine optimization, but that's good for us because we get to utilize it for whatever we want. I should also state that you should also always look at the robots.txt of every website just to be on the safer side, because maybe it is maybe illegal or I don't know. So I have already crawled the websites, and it shows, for example, one chunk, the first chunk, just as a demo. It has a title, summary, the whole context, chunk ID, chunk number, everything, and embeddings a bit further down, timestamp and everything. So what we do is we run crawl Pydantic AI documentation. That's how I named it. And then after it crawls everything, we just do Streamlit run Streamlit UI. So the Streamlit UI is very simple. It just has like text box. You can clear the chat, upload pictures. Actually, Stefan recommended this. So if you are at a meeting, for example, or a presentation or something, you can just take a picture of what you're seeing on the screen. And if you have already crawled their documentation, then you can refer with your own RAG about whatever it is you're seeing. Here, I'm passing a very simple query. I'm sure everyone is familiar with the Pydantic weather agent example. And what we're looking to get is whatever is on the Pydantic website. And I will also copy this so we can run it. So this is the example code that Pydantic provides. This is something close to what we're supposed to see. And if the model does a very good job, it will understand that you don't need all of these. You just need a part, this and that. You don't really need this. And it gives you the exact same thing with less of these inputs and things like that. Fully functioning, it shows you how to do it or what you need to install. And yeah, that's it. The way that you kind of orchestrate the whole operation is by using this other file in which you just pass a simple query. I have to You're an expert at Pydantic AI, a Python AI agent framework with access to extensive documentation. You give it some tools, and it just works. By the way, fun fact, I have also used Pydantic for this project, so that's how the idea even came about. I wanted to know a bit more about Pydantic, and this is how the whole thing works. So yeah.
Hello. That was quick. Maybe I have a couple of questions, but maybe you can explain them, like how you use it on a day-to-day basis on your end.
Of course.
Like, what did it achieve?
So, as I said with the Pydantic AI example, what I was trying to do at first was to have a tool for myself and my colleagues, maybe, so that you could just scrape documentation from different NPM or Python libraries or things that you find on the web, and it would help you better understand it, so you would understand it faster. Instead of you having to go through all the documentation, you could literally just skim it over so you understand where to look, and then you can query ChatGPT or another LLM to give you actual, correct responses. That's how the whole thing came about.
Okay. Okay, cool. I don't know if we have questions in the chat. So for the people, you can ask directly in the Q&A. And otherwise, I'm going to go and ask some questions myself in the meantime. So you mentioned quickly BM25. So can you explain, the role of BM25 in the scoring for with Milvus Full Text Search that you have?
Yeah, of course.
Wait, you froze? Hello again? Can someone in the chat? Okay, you're back. You froze. You were freezing.
Hear me?
Yes, now I can hear
I'm
you.
very sorry. My internet, I don't know. The question was about BM25, yes?
Yes.
Okay, so I will explain how, like, okay, so BM25 basically the reason why you would use BM25, yes?
Yeah. Yeah. What you like? What's the
Okay,
benefit you saw in yourself? Was it when you use it? Did you see like something better than only using vector search?
okay, yeah.
Yeah.
So basically, since the idea of the project was to utilize Milvus in order to make something make something very interesting, so that we could showcase to better understand Milvus and our capabilities as a team. What BM25 is this, I'm pretty sure it's just best matching. It's a retrieval rank search results thing. And what it does on the backend, at least for Milvus' side, why I've chosen also to use it, is because since it allows you to utilize just natural language, it could also have benefits when it comes to how it understands that natural language as like a query by itself. I have noticed kind of different results, like from vector to BM25. At the end of the day, they both use the same kind of logic, but it's a bit of Milvus magic, the way that it works like it does. From my experiments, after a couple of back and forth, a couple of minutes or messages of going back and forth with chat, the vector part starts to get saturated and maybe a bit confused.
Mm-hmm.
I can't really put my finger on why. Maybe it's also part and fault of my logic, like the way that I wrote the script. But the combination of both of them has proven to just bring the best results from each respective query
Yeah.
in this application.
Yeah, no. Also, I can add on that. It's what we see as well with the customers, and in particular, it's very useful if you're looking for specific names or specific brands. Like you're looking for a specific library name, maybe you have another one that is similar with keyword search. Then you will actually find this one and not, another one that would be similar. That's usually a good way. We have some questions as well. So I'm going to ask them. Is like first one is, how do you manage switching between embeddings to string or string to embeddings on request? So I'm
Switching
assuming
to embed.
it's. I'm going to try to rephrase it, and the person let me know if it's correct. But how do you go from like having the query, that you search, to then having the embeddings?
Milvus does that. That's when it comes to full text search, at least Milvus
Yeah.
does that. Because on my end, at least, you just import it, you utilize it, and that's it. On the back end, I'm pretty sure you can go a bit more in detail when it comes to that.
Yes. So basically, yeah, we have our own analyzers and different functions where you're gonna pass the input query, then it's gonna be transformed. So removing, maybe you're gonna put everything in lowercase or something, and then we have the tokenizer and analyzer that is running. So then you don't have to think about the embeddings. That's also why we released full text search. And that way you write text, as an output you get text, and in between, as you said, it's Milvus that is going to use everything here. There is another question, which is it an app strategy for RAG index strategy? So maybe do you have like, I'm going to try to rephrase this one as well because I'm not sure. Did you try different index strategy maybe for your RAG?
Mm. Um, in the past, yeah. In the last couple of months, not really, because I found my bread and butter, which
Mm-hmm.
was just using OpenAI's embeddings and then using a re-ranker, which was either from Hugging Face or somewhere else. But this was my bread and butter because up until recently, I had never had the need for such a complex solution to RAG because I didn't have the need to go through hundreds of websites and query them at the same time.
Hmm.
So I hope this was a good enough answer.
Yeah. And I guess we kind of replied to it, but just gonna ask it again. So, did you try to combine vector with sparse embedding models? So, like BGM3 that we have in Milvus. So, did you try sparse and vectors? Just to understand, the advantages of using full text instead of sparse embeddings.
So in when I started working on this tool, I have tried many different combinations of many different things, but at the end, I don't know if it was just convenience plus performance, but I kept going back to this vector and full text solution. It just seemed to give the better answers all the time, because with the other like combinations, I would also just get some very good response and then a completely out of the park, like query response. This was the perfect balance to whatever I am working on, because at the end of the day, what I envision as a user for this is someone who also has an understanding of what they're looking at and what they're going through. So you have to be a bit more specific, maybe, and but it usually has produced better and more reliable results. I have been using this for uh, a couple of days minimum.
Cool. And also to add to your response, so one of the advantages of using full text instead of sparse embeddings, when you use sparse embeddings, you have to compute them yourself usually, which can be tricky. You have to update the statistics yourself. Whereas with full text search, basically we take care of that for you, so you don't have to have another pipeline. That is doing that as well. There is one which is quite long.
Yeah, I'm
So I'm
reading it. This seems like
currently building something utilizing Crawl4AI and Zelis, basically monitoring financial news and adding RAG capabilities on top. I had two issues. I'm face I'm facing one. There's a lot of articles are very different in length. Some are extremely long. So what should be my approach to chunking? And the other one is that they differ in languages. How would you embed multilingual documents? How would you embed it in the same space or separate for each language? I already have a multilingual embedding models. Let's go for
okay.
those two, and then we'll have the follow-up questions after.
So first of all, pretty interesting project. I'm not even gonna lie. This has some very good, especially if you're into stocks and things like that. So about the chunking thing, this is how I personally would go about it, and this is what I kind of have done in this project as well. So I keep track of chunks in two ways: the ID of the chunk, like every chunk has its own ID, and then the actual chunk number of the specific single website that you're reading, that you're crawling. That's how I would do it. And then the very last chunk of that specific website, that's going to be a bit shorter. But I really don't think that that's that big of a problem, because usually, and especially in financial articles and things like that, the meat is in between. So that's in my opinion. And then about the language part, I have experimented with different embedding models for different languages. I still am sad or whatever to say that the best way to go about this is to translate them to English, because it will never perform the same. If you use a multi-language model, like embedding model, it has the drawback that it's trained on more on different languages, multi-language. So I personally would just translate whatever article in English and then resume with the chunking logic and then the embedding logic. And then for the very last part, I really, especially when it comes to financial, I really personally would use BM25 and ANN. Like,
Mhm.
yeah, but I that's how I would do it.
Cool. Thank you. And yeah, I think you already mentioned it's a bit, but like the performance for hybrid or semantic search, you said basically by using full text search, you have better performance, right? The first question you have in the Q&A.
Yeah, and it and in my experience, it really has. I have yet to find a single drawback, like something that really makes me question the whole solution. There might have been caveats, but I don't even remember them.
Mhm.
So it's worked out pretty well.
Cool. Just gonna wait 1 or 2 minutes to know if we have more questions from the people. Otherwise, yeah, maybe they can add you on LinkedIn or somewhere. Where can people follow up if they have questions?
Okay.
They can add you on LinkedIn.
Yeah, pretty sure LinkedIn if you have it, or either
Yes.
my LinkedIn or my GitHub. Yeah.
Just waiting quickly, and then we'll see. Otherwise, we don't wait one. We're at 30. If we don't have questions, we can close this one. But yeah, that was very interesting. I mean, the use case is also interesting as a more than a toy project as well. So
Mhm.
this is quite cool.
It's being used on the daily. It, of course, it has room for improvement. As I mentioned, like preferably, I would like to implement some logic that differentiates different uh, sitemaps, so of different projects
Hmm.
or libraries. But I have yet to work on something that complex,
Hmm.
so I didn't need to refer to multiple things at the same time. Like it's been fine.
Okay. Okay. It seems like yeah, there's no more questions. Well, thank you very much for the presentation. Thank you everyone. Sorry for attending. We will follow up with the recording, so you will see it in a couple of days. And we'll see you soon on my end. I actually see you next week for the other webinar, which will be with Feast on how you can do real time RAG. So thank you very much. Have a lovely morning, afternoon, or evening, wherever you are in the world. And goodbye.